All right, this is a lesson for our topic of nomenclature, where we are going to be looking at the Oxy Radicals, which I've spelt wrong up here. Um, so our Oxy Radicals. Now, our Oxy Radicals are basically a polyatomic ion that has a different number of oxygens from what we've seen before. So I want you to think back to our eights, those polyatomic ions that we've learned in the past. So our examples are right here. Carbonate, chlorate, fluorate, bicarbonate, nitrate, phosphate, sulfate, iodate, and bromate. These are the eights. And I have mentioned to you in the past that it is going to be in your best interest if you know those eights, if you have the names and the formulas of these eights memorized. That's because it makes naming our oxyradicals a little bit easier if you can easily recall the formula of the eight. So, eight oxyradical, and sorry, I'm just going to go back. It's just in your best interest if you are going, it's in your best interest for you to copy this video lesson down into your notes. So hit pause and copy as we are going through this. So we have our eights here. And if we continue, a oxyradical is basically a polyatomic or an eight that has gained or lost an oxygen atom during a chemical reaction. So because it has a different number of oxygen atoms, we have to change its name because now it's a completely different compound. So in order to name our oxyradicals, there's a little bit of a system that we can use that involves our eights. So hit pause and get this copy down. So we're going to look at sulfate today. And we're going to consider sulfate, SO4 with a 2 negative charge, our home base, our 8. Now, an oxyradical is one that has changed number of oxygens. So we're going to come over here and we're going to see what happens. It's a terribly drawn arrow. If we lose one oxygen, so lose one O. So if we lose an oxygen, we still have SO, but instead of 4, we end up with SO3. Now, it still maintains the ionic charge 2-. But because we have a different ion involved, we have to give it a different name. So instead of being an 8, this SO2 negative or SO3 with 2 negative charge becomes, instead of an 8, it becomes an ite. So this ion is called sulfite. And it gets the ite because it has lost one oxygen. Now, if we go back to our home base, our 8, and we lose a second oxygen. So, whoa, that is not what I wanted. So we go back to our home base and we lose from our home base. Just another terribly drawn arrow. But this time we are going to lose 2 oxygen atoms. So again, we still have SO, but because we went from 4 and we lose 2, we end up with 2 oxygens, and we still keep the 2 negative charge here. Because this ion is different from sulfate and sulfite, it has to have a different name. So this becomes hypo, whatever, ite. So the name of this ion is hyposulfite. sulfite. And it's an hyposulfite because it has lost 2 oxygen atoms from the 8. We can go the other way. Instead of losing oxygen atoms, our 8, again, that's not what I wanted. Our 8 can gain oxygen atoms. So we're going to come over here. And what happens if we gain 1 oxygen atom? So if we gain an oxygen atom, come on, there we go. We still have SO, but instead of 5, we now have, instead of 4, we now have 5 oxygens. And this ion still has an ionic charge of 2 minus. Come on. There we go. All right. Now, because, again, the number of oxygens has changed, we have something very different than what we had before. We cannot name this sulfate. We have to name it something different. So when it has gained an oxygen, it gets the name per 8. So this ion, I'm just going to scroll up a little bit, is a per sulfate ion. And the per sulfate naming, so it's got a prefix and a suffix, is whenever a polyatomic, whenever an 8 has gained an oxygen atom. So this is the system. The name depends on the number of oxygen atoms. The changing in number of oxygen atoms, and therefore the corresponding name, is consistent with every single 8, so chlorate, nitrate, phosphate, that we have learned. A phosphate with 1 less oxygen becomes a phosphite. A phosphate with 2 less oxygens becomes a hypophosphite. So the naming system that you see here, I've shown it with the sulfate ion, but it is the same for all of the 8s that we have learned so far. The one thing I want you to notice is that if we were to pay attention, the per sulfate has a charge of 2 negative, the sulfate has an ionic charge of 2 negative, the sulfite has a charge of 2 negative, and the hyposulfite has a charge of 2 negative. That's really, really important because the ionic charge always stays the same no matter the different change in oxygen atoms. So the per sulfate, sulfate, sulfite, and hyposulfite all have a -2 charge or 2 negative charge. A per phosphate, a phosphate, a phosphite, and a hypophosphite are all going to have a 2 negative or 3 negative charge. Okay. Now, all of these are ions. They all have an ionic charge. So they can all bond with a metal to form with an ionic compound. We're going to do a couple examples in a minute. But first, I want to show you something on your periodic table. So we'll just open up my periodic table. You have a copy of this. And if you look on the side of your periodic table, the alkane periodic table of ions right here, and in this box right here, this is where I told you already, you would find an awful lot of the polyatomics. If you look and you scroll in, it's kind of blurry because of the photocopier, but the rules that I just showed you are in this box in the corner. So you can see that it tells us 8 is most common. Per 8 has 1 more oxygen. Ite has 1 less oxygen, and hypoite has 2 less oxygens. So the rules that I just showed you are actually right here, and you don't have to memorize them. You just have to know how to use them. So the 8, the most common, is in this box, this big box, right here. And then the rules for naming the oxy radicals are in the yellow box on your periodic table. So when you are doing examples, for instance, and you see a carbonite compound, you can come over here and find that you have carbonate, CO3, 3 negative, but it's carbonite. So over here, it's telling you that it's 1 less oxygen, so you can very easily figure out that carbonite ion is CO2, 3 negative. Okay. So you don't have to memorize these rules, but you're going to do it a lot quicker if you know the rules and very easily can recall formulas and give names. So we're going to do a couple examples. So make sure you have hit pause and you have copied this down. And we're going to do just a couple examples. So the first example we're going to look at is just a plain polyatomic, one of the 8 that we already know. We're going to name or give the formula for sodium nitrate. So we're going to use the same rules we did before. Sodium, symbol for sodium is Na with a plus. And our nitrate is NO3. And I know this because I memorized my 8s, and it's a -1 charge. We're going to do our crisscross that we have learned how to do already. And what we get if we do that is Na. Get my color back here. We get Na with a plot, a 1, which we're not going to draw, and an NO3, which we're with a 1, which we're also not going to draw. Okay, so that's sodium nitrate. And the same rules work for sodium nitrite. So sodium, Na plus, our nitrite, wrong color. Our nitrite is not NO3. We should recognize that we have ITE here. So that means instead of NO3, it's actually NO2 because we have lost an oxygen. The charge is still -1 or -1. So we still crisscross down. Okay. Now the crisscross rules still apply because you still have to check if you have a multivalent metal and if the ionic charges are correct for the nonmetal. Okay. So be mindful that this is just another negatively charged ion that can bond with a regular metal or a multivalent metal. We'll do one more. We'll look at magnesium hypofluorite. So we know that magnesium is Mg and it has a 2 plus, and hypofluorite. So if you don't know this off the top of your head, what you're going to do is you can either go and remind yourself that fluorate is FlO3, and hypoite means it has lost 2 oxygens. So hypofluorite is going to be FlO, and it has a charge of -1. So we cross this 2 down here. The invisible 1 comes down here. I'm going to come over here. And we end up with Mg, FlO2, but remember that 2 belongs to the whole thing, so the hypofluorite gets put in brackets. Now you're going to notice that if you went to try to find fluorite or fluorate in your table of complex ions, it's not there. Okay, so it's one of the very few that is not in this table, but I'm going to show you a little trick. Fluorate is Fl. Why does it have an L? Definitely should not have an L. There's no L in fluorate because fluorine does not have an L. I don't know what I was doing there, guys. No L. All right, back to my trick. You're going to notice that fluorate, chlorate, iodate, and bromate, which are all halogens, actually have exactly the same formula for their 8. They are all the halogen, 3 oxygens, and a -1 charge, or 1- charge. So if you can remember that fluorate is basically exactly the same as chlorate, except it's a fluorine instead of a chlorine atom, then its formula, it will be easy for you to remember. Okay. All right. Now naming, we do exactly the same as we have named before. In this example, we're going to do a couple examples where we're going to name together, and I'm going to walk through the whole process. Ca, we know, is going to be calcium. And then we notice right away that we have a PO5 in brackets. Now you should immediately recognize that this is a polyatomic. Now if you've memorized the 8s, this is going to be very easy for you because you know that phosphate has 4 oxygens. So this has 5. So you know that this is going to be per phosphate because you have gained an oxygen. If you have not memorized the 8s, that's when you have to go to the table on your periodic table, find phosphate right here, see that it's PO4 3 negative, and then recognize you've gained an oxygen. Come over here to this chart and see that you have it's per 8 because you have 1 more oxygen. Because calcium is not a multivalent metal, we don't have to check any charges. All right, we'll do the next one. Ba, easy enough from your periodic table, barium. And then CO2. CO2. So you cannot, if you don't recognize that, you need to go to your 8s, CO2. Well, carbonate is CO3. So that tells us that we have a carbonate -1 oxygen. So this becomes carbonate. So the name of this one is barium carbonate. Now for our last one. In this one, we have iron. So we're going to go iron. But you should recognize that iron is a multivalent metal. So we have to do a reverse crisscross. This 3 comes up here, and the invisible 1 comes up here. So after you do a reverse crisscross, you need to check and see if you have the correct ionic charge for your nonmetals. Now, NO looks to me like it's a version, or it is a oxy radical of nitrate. And because I memorized my 8s, I know that it has an ionic charge of 1-. So I know that I don't have to do any changing. The formula has not been reduced. So this is iron 3. And then NO looks like it's a nitrate that has lost 2 oxygens. So nitrate is NO3 and this is NO, so 1. So this means that the name for this one is hyponatremia. nitrite. All right, so those are just a couple examples of naming and determining formulas for ionic compounds that are containing an oxy radical. Use your periodic table to help you. The more you practice, the better you will get at naming. So what I'm going to ask you to do for practice is head over to our website under Oxy Radicals. There is a little bit of practice, 10 examples, 5 names, 5 formulas of just oxy radicals. And then then there's answers for you to check. Then if you keep scrolling right here, this is a collection of all of the nomenclature we have done so far. So this will really test you, but it's important to do a big mix so you get used to having to think about what type of ionic compound you are naming. Okay, so once you have worked through some of this practice, then the answers are here for you as well. Now make sure that you do the practice without just checking for the answers. Okay. Other than that, that's all for now, guys. So this has been a video lesson where we have been looking at how to name ionic compounds that are containing oxy radicals. Do some practice.